Hey everybody, we're inside Frore's booth here. This is a CES Innovation Award winner, providing a technology that many of us don't often think about, but plays a huge role in all the devices we're seeing here at the show. I'm joined by Seshu here, the founder of the technology. Tell us more about what you're bringing to market.
Sure. So we are Frore Systems, and we've developed the world's first solid-state active cooling chip. What we do is provide a completely new revolutionary thermal solution. Typically, computing devices generate a lot of heat, and in order to remove the heat, people use very conventional solutions like heat sinks, vapor chambers, and fans. But those are all pretty old technology. One could say more than 100-year-old technology. So what we have done is actually produced the world's first chip, solid-state active cooling chip. This completely replaces all the old traditional thermal solutions like heat sinks and fans, and does the job of cooling computing devices by just using a chip. This is the AirJet Mini. It's only 2.5 millimeters in thickness, and this can remove 5 watts of heat. In fact, this has another party trick to it, and that is very high back pressure. Back pressure is important because when you have computing devices and this chip is operating in a computing device that's very small, you have a lot of resistance for airflow in the channel. And high back pressure helps you to be able to ensure peak performance even in a very constricted channel. For example, the amount of back pressure this produces is equivalent to what a fan of this size would be required to produce the same amount of back pressure.
Well, let's get a look at some of the devices back here where you're showing how this power works. And it's amazing how many different types of devices you have with this technology built in.
Here's one of the commercial products that's currently in the market today that's using AirJet. This is an ultra small mini PC. And the manufacturer of this mini PC is Zotac. They had a huge problem when they were building this mini PC because of the size of the PC, they found that the processor can only run at 2 watts of power, even though the TDP of the processor is 7 watts. So by adding 2 AirJet Minis inside, without changing the size of the device, we're able to help the CPU operate at full 7 watts in a sustained fashion. So we were able to improve it by 3.5 times the performance by adding 2 AirJet Minis into this ultra-compact mini PC.
Great. Okay, and then over here we have the type of laptop I have an edit on, and let me tell you, it does heat up, so I could really use a device like this. This is the MacBook Air M2 15-inch. Tell us about how you're using your chip inside this laptop.
Sure. So the MacBook Air 15-inch is perhaps the world's thinnest laptop and is famously fanless. Because it's thin, there isn't enough room to put a fan in there. But the downside of that is that even though the processor in this MacBook Air 15-inch is a very powerful processor, Apple Silicon M2 processor, because it's fanless, the processor throttles. The device gets very hot, but in spite of the device getting hot, the processor throttles. So you lose 30–40% performance because of the thermal limitation of the MacBook Air. So what we've been able to do is, because our chip is very thin, it's only 2.8 millimeters in thickness, we were able to put our chips, 3 of them, inside the MacBook Air in the same form factor. There is a 3.3 millimeter gap inside the MacBook Air between the back cover and the keyboard. And that's enough for us to be able to insert 3 AirJet Minis inside the MacBook. And we were able to deliver the full M2 processor performance. So we were able to show that by putting 3 of these AirJet Minis inside the MacBook Air 15-inch, you can match the performance of the MacBook Pro. So you don't have to buy a thicker, noisy, more expensive MacBook Pro. You could just put 3 AirJet Minis inside a MacBook Air and get a super slim device that's silent, but delivers the same performance.
So I do want to ask you about the market rollout here. Is this something that would be on the consumer to install, or do you work with partners who then outfit the laptops to bring them to market with these chips, or is this something that Apple would even put into its laptops? How do you roll it out?
This product that we have shown here, the commercial product, the Zotac Mini PC, is something we worked with the manufacturer. The integration of the AirJet Minis into the device is not trivial. So this is something that has to be done by the manufacturer as part of their manufacturing process. Retrofitting is possible, as we've done here, but this is only for demonstration purposes. We wouldn't recommend the consumer doing that. So we work with device manufacturers and engage with them very early on in their design cycle to make sure that when they design the product ground up, they're doing that with the AirJet Mini capabilities in mind, so they get the best performance, and also they are able to produce devices that are really thin and light and mobile, but yet delivering high performance.
Right, and we were talking about earlier how consumers are just demanding so much more from their devices today, all types of devices, as we look to embed AI onto a device. Now, over there you have smartphones. Let's go take a look at that over there right now.
Here's a demo we have of a smartphone that we've rigged up with the AirJet Mini, and we're able to improve performance by 40%. Because smartphones also have the same problem. The processors in these devices are very powerful nowadays, but because of the limited thermal performance of the smartphone, the processors are massively throttled. So by adding AirJet Mini, you can improve the performance by 40% of an existing processor.
40%, that's a noticeable impact for sure in terms of what you can accomplish.
Another area where we're finding that we can make a big difference with our solid-state active cooling chip AirJet Mini is SSD. Nowadays, SSD memory, solid-state memory is becoming more and more important in computing devices. And in order to ensure high performance, the standards have evolved to PCI 4 and PCI 5, and also in terms of peripheral connections to things like Thunderbolt 3 and Thunderbolt 4. They actually support very high bandwidth of read and write into the NAND memory. But because of thermal issues, very often the speed at which you can read and write is massively throttled. Here's an example of a SSD accessory connected with Thunderbolt. What we are finding is that, as is, the bandwidth is reduced by 66% because of thermal. By adding AirJet Mini inside the same accessory, you can actually realize the full performance. So without AirJet, it throttles to 1 gigabyte per second, and by adding AirJet, you can get the full 3 gigabytes per second performance for the bandwidth of read and write into SSD memory.
All right, and lastly, you have slightly out of the box from all the devices here, lighting, which you think about all the smart city applications going up, or even just the transitions that consumers are making in their own homes with their lights to LED to be more sustainable. How are you helping these devices become more sustainable and efficient?
Well, that's the thing, right? It's not just computing devices that have heat issues. There are all sorts of devices in the world, and here's a good example. This is the LED light. This is an architectural LED light, which is a very high performance light, produces beautiful white light, and it's recessed in the ceiling. And it's recessed in the ceiling where you got all sorts of insulation in the ceiling. And when you do that, in order to keep the LED light cool, they end up having to use a very big case, metal case, and inside the metal case, on top of the LED light, they have a massive heat sink. That's what it takes to remove the heat that is produced by the LED. Now, we can actually eliminate all of that by just replacing it with 2 AirJet Mini. So you can reduce the volume, as you can see, by 90%, and you can reduce the weight by 72% for the solution. So you can deliver the same LED light performance in a much thinner and lighter form factor by using AirJet Mini compared to the conventional solution.
Wow. Well, it's certainly interesting to see just how big this market is by looking at all the devices around this room. What do you hope is your big differentiator in the cooling technology space?
Well, what we have done is one of a kind. There hasn't been any innovation in thermal in a century. So what we have done is actually produce the world's first solid-state active cooling chip. And in order to do that, we had to actually build this from scratch using new materials, new design techniques, new manufacturing processes, and bring it to fruition and to high volume production. And that's what we've done. And we are really happy with the response we are getting from the industry, because this solves a major pain point in computing and even non-computing devices. And we think that we've come up with a very unique way of solving the problem that's a real problem and is causing a lot of lost productivity and performance.
Well, thank you so much for your time today. It was great
you very
to
much.
meet you and see all your technology in action. And everybody can stay tuned for more coverage like this from the show.